I'm Victor Carl Chan, and I'm a PhD candidate at the University of Toronto. I'm a cosmologist, which means I study the origin and evolutions of the universe. Before the Big Bang Theory, we used to think that we lived in a static universe. This means that we thought the universe has always been around and it's always been the same. This wasn't that crazy of an idea at the time, and Einstein actually built this into his theory of relativity when he came up with it. Very soon after this, we started to make observations that would contradict the idea of a static universe. One of the most important pieces of evidence against the static universe is when we look at faraway galaxies, they're actually moving away from us. And we also noticed that farther galaxies actually appear to be moving away from us faster. If we turn back time, then we know that these galaxies used to be closer together at some point. And if we turn back time all the way to the distant past, then there was a point at which they were packed very closely together. We also know that if we compress matter, it tends to heat up. So putting that all together, if we wind back time far enough into the past, then everything must have been packed very closely into a single point, and it also must have been very hot. This is the idea of the hot Big Bang. I already touched on one of the most important pieces of evidence for the Big Bang, which is that distant galaxies appear to be moving away from us. Another important observation is the cosmic microwave background, which is a very bright microwave signal that we observe coming from all directions in the universe. The cosmic microwave background can actually be explained by a very hot and dense phase in the early universe. So far, we haven't really made any direct evidence that would contradict the Big Bang Theory. We can try to come up with other ways to explain the receding galaxies and the cosmic microwave background. But the Big Bang Theory is really one of the most simple ways to explain both in a very elegant way. The definition of a scientific theory is that it's an explanation for why we observe certain natural phenomena, whereas a scientific law tells us that certain things will happen a certain way. For example, the law of gravity tells us that if we let go of objects, they'll fall to the ground because of gravity. The theory of relativity tells us why the gravity happened. There are plenty of theories that we think are pretty accurate, such as the theory of relativity, most of quantum mechanics, and the theory of evolution. If we do eventually find evidence that would directly contradict any of these theories, that's totally fine. It just means that we have a lot to learn, and when we do learn about them, we can come up with new theories that would explain all of it.